This is lesson 32 for 8th grade, and today we're talking probability. I enjoy working with probability because it has a lot of real-life application, and this is something we have worked with before as 7th graders, but today we're going to step it up just a little bit and make things a little bit more challenging, which always makes things fun. So, part of what we want to do today, we want to review the definition of probability. We want to understand the difference between chance and odds, so we have some different ways to express probability. We want to determine the sample space of different events, and we're going to want to understand the difference between experimental probability and theoretical probability. Alright, so first of all, here's our definition. Probability is the likelihood that a particular event will occur. And to express this probability of event A, well, let's say we have an event and we're saying event A, so we would use this notation P of A. This basically says the probability of event A happening. So you're going to see me use that notation quite a bit. And we can express probability as a number ranging from 0 to 1. Okay, so let's say we get the probability of an event 0 out of however many outcomes there are, that would be an impossible event. So the probability of 0 means that can't happen. We say anything less than half or 50%, we would say that's unlikely. So if we think weather, we think like a 20 to 30% chance of rain, it's not likely. It could still happen, but a good chance that it will not. Anything greater than half we would say is likely. And if you get a probability of 1, that's certain. That's 100% chance. Okay? So basically, probability is a ratio of favorable outcomes to the total possible outcomes. So number of favorable outcomes over the number of possible outcomes. All right. And before we move on to that example, that should show you why a probability of 1 means certain, because if your favorable outcomes matches your possible outcomes, you get the same number over the same number, which is, I don't know, let's say 10 over 10, which is equal to 1. Okay, so let's look at this example. It says the spinner shown at the right is spun once. What is the probability the spinner will stop in sector A? Okay, well, using our formula, we're taking P of A. We want to figure out our favorable outcomes. A favorable outcome would be the spinner stopping on A. Well, one of those sectors is A, and we've got 4 possible sectors. So the probability of landing in sector A would be 1/4. Letter B says, what's the probability of landing in sector A or B? So probability A or B equals what? Well, A or B, that's 2 of our sectors, and that's 2 of the 4. So that would be 2/4 or 1/2. And our last one, probability that we land in sector A, B, C, or D. Well, that is all of our sectors, so the probability of that happening is going to be 4 out of 4, or 1. So that is a 100% that it actually will happen. Okay? So that would be a couple examples of how we find probability. Should be a bit of a review. Alright, oops, sorry. Now it says probability may be expressed as a fraction, as a decimal, or as a percent. We often use the word chance when expressing probability in percent form. So in example 1, where we found the probability of landing in sector A, that was 1/4. If we turn that into a decimal, we get 0.25, and we can turn that into a percent, which is a 25% chance. So think about weather, like I mentioned before. Usually when they say the chance of rain, let's say it's 30%, they'll usually say 30% chance of rain or 20% chance of rain, something like that. So whenever we use chance, that word, we're talking percent. Okay? Odds. Odds is the ratio of number of favorable to unfavorable outcomes and is often expressed with a colon. So if we look at this question, what would be the odds of the spinner stopping in sector A? So remember we had, this was 1/4, and we found that it was 25% chance in sector A. The odds, this would be more like your lottery ticket type format. If you look on the back of it, it gives you your odds of winning. So the odds of the spinner stopping in sector A would be number of favorable outcomes, which would be landing in sector A. That would be 1. And we're going to do favorable outcomes to unfavorable outcomes. Well, landing here is the favorable outcome. Landing in one of these three would be unfavorable. So odds would be 1 to 3. So odds would be 1 to 3. Chance would be 25%. And your probability would be 1/4. So that's the difference between odds, chance, and probability. Alright, now let's get into sample space. Sample space of an experiment is the collection of all possible outcomes. And we can record the sample space in a variety of ways, including a list or a table. And we're going to take a look at this right here. If we toss a coin twice, there are 4 possible outcomes. This is the table that they use. Let's say on your first toss, you're either going to get a heads or tails. And on your second toss, you're either going to get a heads or a tails. So then we combine by columns and rows. Heads, heads here. Tails, heads. Heads, tails. Or tails, tails. Now, order does matter here. So the number of outcomes would be 4. So these two technically are not the same, even though you get the same. You still get the same outcome. So tails and heads. So yes, you get the same outcome, but we still count them as separate events. So if they ask you for if we look at this question here, can you find the probability of getting heads at least once in 2 tosses of a coin? Okay. So getting a heads at least once in 2 tosses, we could say, okay, well we get a heads at least once here, heads at least once here, and here. That would be 3 out of the 4 possible outcomes. So we still count them separately. Alright. This is a table that could be used. I do things a little bit differently, which I'll show you in a second. And just so we know, sample space is always written out with, so you'll have your total outcomes listed here, and then the brackets on either side to show that that's your sample space. Check my video time. Okay. And we have talked about this last year as well. Alright, so sometimes using a tree diagram is helpful, and we're going to see how that works with this example. This is how I like to do things, and we'll see if hopefully you like to do it too. So it says Nathan flips a coin 3 times, and what we're going to do is predict which is more likely, that he will get heads at least once or that he will not get heads at least once. So what would be more likely? If he flips it 3 times, would you expect that he's going to get at least 1 heads, or would you think that he's not going to? Well, flipping a coin once, we've got a 1 in 2 chance, or a 50% shot of getting a heads or a tails, and he's flipping it 3 times. I would say that he will probably get heads at least once. So I would say for a prediction that would be accurate right there. and it wants us to find the probability of getting heads at least once, and find the probability of not getting heads at least once. So what we have to do is figure out all the possible outcomes here. So, to do that, we're going to use a little tree diagram. And we've got three flips. So we've got one flip, let's say first flip, second, and then we have a third. Hopefully this all lines up okay. So in your first flip, let's start here. First flip, you're either going to get a heads or a tails. Okay? Now from there, you're going to flip again. And once again, you're going to get, if you do get a heads, you're going to flip again. You're either going to get a heads or a tails on your second flip. And no matter what you get here, say heads or tails, you're going to get a heads or tails on your third flip, okay? And that's how it's going to go here. No matter what on your second flip or your third flip, you're either going to get a heads or a tails. Heads, tails. So in order to find out how many outcomes we would have, we can count up all these last ones. We'd have 1, 2, 3, 4, 5, 6, 7, 8. 8 possible outcomes. Our sample space would be we'd have to list out all the possible outcomes we would have. So we just follow these in order then. We could get a heads, heads, heads. Heads, heads, heads. I'm having trouble today. Okay, we're gonna leave it like that so I don't screw it up anymore. We can get a heads, heads, tails. I could get a heads, tails, heads. So we're basically listing out all the different ways we could order these letters around, basically. Our next one, heads, heads, tails, tails. And that's all of our possibilities of getting a heads first and then our outcomes after that. We could get a tails, heads, heads. So we're basically following paths now. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. Or all tails. So, sorry, I kind of ran out of room there. Normally we would list them all out in one order there, and then close it off with another bracket there. See my time. Alright, we're at about 14 minutes, so I will turn this into a two-parter probably. So let's turn it into two parts right now. So stay tuned.